All right, let's take a look at our practice test. We want to use a calculator to find each. We're going to round to the nearest 10,000th. So looking at the first problem, we have the cosecant of negative 560 degrees. So for a lot of you, you're using an online calculator, so you can just type this in directly and it's not an issue. But for others, you're using some sort of calculator and there's no cosecant button. So in that particular case, you need to use your reciprocal identity, where basically you say that the cosecant of theta is equal to 1 over your sine of theta. And for this one, I would say this is equal to 1 over your sine of negative 560 degrees like this. So I would start by just hitting the 1 on the calculator, the divided by key, then the sine key, and then basically you have parentheses that open up. Just type in negative 560. You don't need the degree symbol. Your degree mode should be on. You can check that really quickly by doing sine of 90 and you get 1, so you know you're in degree mode. So once you've typed that in, just close the parentheses, or sometimes it does it for you, and just hit enter. So this is going to give us approximately here 2.92, and then let me go 380, and my calculator stops after 44. Your calculator may give more digits. But again, we are going to round this to the nearest 10,000th. So in case you don't know, this is the tenths, hundredths, thousandths, and this is the 10,000ths, okay? So we want to round to that. So we would look at the digit that follows. So in this case, that's a 0. So that tells me that this 8 is going to stay unchanged. And I can just delete all of these, right? They won't add any value to the number if I change them into a 0, so you can just get rid of them. So the approximate answer here is 2.9238. Okay, let's look at problem 2. So now we have the sine of 230 degrees. So in this particular case, this problem is interesting because we have a negative value. And sometimes students will have trouble rounding when there's a negative. So let me show you what to do here. So first and foremost, you know that this is a negative answer because 230 degrees is in quadrant 3 and sine is negative in quadrants 3 and 4. So if we punch this into the calculator by hitting the sine key and then followed by the 230, and then again, you might have to close your parentheses, you're going to get approximately, I'm going to put negative 0.766. Let's go 0, and then I've got 4, 4, 4, 4, and then 3, 1, and that's where my calculator stops. Again, yours may give a different number of digits or change some things at the end. It's just based on how your calculator works. But we want to round this guy. So basically, I'm going to the nearest 10,000th. So tenths, hundredths, thousandths. This is the 10,000ths place. What I would do is pretend that this is just a positive number and forget about the fact that it's negative, because people get confused when you start talking about rounding up or rounding down. So I just look at this digit that follows here. So if this is a 4 or less, then this digit stays unchanged, right? So I don't have to do anything here. And then basically, because we're working with a decimal number here, if I change all of these numbers that follow into a 0, they don't add any value, so you can just get rid of them. So I'm basically going to cut all this off. This 0 here wouldn't add any value, so you can cut that off. So the answer here is just negative 0.766. So if you're rounding with a negative, just use your normal procedure. Don't worry about the fact that it's negative. You can just think about it in terms of its absolute value, use your procedure and round, and then just consider the negative after. Okay, let's look at problem 3. So here we have the secant of 200 degrees. And again, you might not have a secant key. So the secant of theta, again, is equal to 1 over your cosine of theta. So you might have to say this is 1 over the cosine of 200 degrees, just to punch it into your calculator. So you hit the 1 key, the divided by key, the cosine key, in the parentheses type in 200, and just hit enter. And so this is approximately going to be negative, we have 1.064, and then I'll go 1777772, and that's where my calculator stops. We know that cosine would be negative and also secant would be negative in quadrants 2 and 3. A 200-degree angle is going to be in quadrant 3, right? So we know it's going to be negative with the cosine value or the secant value. Now, in this particular case, we have a negative again. So this is where people get tripped up on rounding. Just again, pretend like this is positive. Don't even consider the negative. You're just going to go through and find the 10,000ths place. So tenths, hundredths, thousandths, 10,000ths. So right there. And just look at the digit that follows. So right here, This is going to be a 7. So that means I add 1 to this digit. 1 plus 1 is 2. So this becomes a 2 here. And again, you could just cut off all these digits because what happens is they turn into a 0, and then the zeros don't add any value, so you can just delete them. So the answer here is about, or you could say approximately, negative 1.0642. All right, for problem 4, we have the cosecant of negative 550 degrees. And again, you might not have that button on your calculator. So let's say the cosecant of theta is equal to 1 over your sine of theta. So this is equal to 1 over your sine of negative 550 degrees. Now this guy is going to actually be positive. If you added 720 degrees to this angle measure, you would get a 170 degree coterminal angle. So that's in quadrant 2. And sine and also cosecant, they're going to be positive in quadrants 1 and 2. So let's say this is approximately, I'll say 5.75877048.3. And again, we're rounding to the nearest 10,000th. So tenths, hundredths, thousandths, and then 10,000ths. So right there. And again, the digit that follows is a 7. So that means I'm going to add 1 to this digit right here. So 7 plus 1 is 8. And once again, you can just delete all these digits that follow. So this is going to be approximately 5.7588. All right, for the next few problems, we want to find the exact value. And for problem number 5, we have the inverse sine of, you have your negative of the square root of 2 over 2. Now this is very straightforward to just punch into the calculator, but the answer might be very confusing for you. So if you punch this into your calculator using your inverse sine key, or some calculators will write it as arcsin like this. Again, it just depends on your calculator. Well, essentially what's going to happen is you're going to get negative 45 degrees. So let me stop for a moment. If you understand where this comes from, then just move on. But if you don't, let me explain what's going on here. When we think about the sine of theta, so the sine of theta, remember this is the opposite over the hypotenuse. So if I hit the sine key followed by an angle measure, then I'm going to get this ratio here, right? My calculator will spit that out. If I go over and say the inverse sine of this opposite over hypotenuse, well, that's going to give me the angle measure back. But the problem is, when we think about the sine function in general, if you looked at y equals sine of x on an online graphing calculator like Desmos or something like that, you're going to see that it's not a one-to-one function. Remember, for a one-to-one function, for each x there's one y, and for each y there's one x. Well, y equals sine of x is not a one-to-one function. It fails the horizontal line test. So what ends up happening is we have to restrict the domain of our sine function in order to get an inverse. And we're going to talk more about this later on. But essentially what's going to happen is if you get a positive answer from this guy, you're going to be in quadrant 1. And if you get a negative answer, you're going to be in quadrant 4, and you're going to rotate clockwise. But for right now, if you get an answer of negative 45 degrees, you have to do a little bit of thinking there. Okay, so I'm in quadrant 4. The coterminal angle would be me adding 360 degrees to negative 45 degrees, so that's 315 degrees. Now, if I sat here and said that the sine of, let's say, theta was equal to the negative of the square root of 2 over 2, and you said that theta was negative 45 degrees, you would be only partially correct, right? There's an infinite number of angles whose sine value is going to be negative square root of 2 over 2, okay? This is just something we can use to say that, okay, well, I know sine is going to be negative in quadrants 3 or 4. And then I can just say that, well, I would want to have a 45 degree reference angle. So theta could be 315 degrees, right? That's in quadrant 4. It has a 45 degree reference angle. Or it could also be 225 degrees. Again, that's in quadrant 3 and it has a 45 degree reference angle. And then you can find an infinite number of coterminal angles with those two angles to produce a sine value that's going to be the negative of the square root of 2 over 2. So again, I don't want to go too far into this because we're going to talk about it later on in the course, but I know a lot of students at this point get very confused when they get an answer of negative 45 degrees. All right, let's take a look at problem number 6 now. So we have the inverse tangent of the square root of 3 over 3. So this is fairly straightforward. You could just punch this into your calculator. You're going to get an answer of 30 degrees exactly. But again, if you're thinking about this in terms of, let's say I had tangent of theta was equal to the square root of 3 over 3, and I wanted to figure out, well, what is theta? Well, there's an infinite number of angles where you take the tangent of it and you get the square root of 3 over 3. This right here, this 30 degrees, you just think about that as your reference angle. So tangent is going to be positive in quadrants 1 or 3. So any angle that's 30 degrees or coterminal with 30 degrees is going to have a tangent value that's square root of 3 over 3. So for example, 390 degrees, right? The tangent of 390 degrees would also be the square root of 3 over 3. But additionally, if you think about in quadrant 3, your tangent value is also going to be positive. So you could say in quadrant 3, a 210 degree angle would have a 30 degree reference angle. So the tangent of 210 degrees or the tangent of any angle that's coterminal with 210 degrees would also give you the square root of 3 over 3. So it's just something to keep in mind for later on in the course. All right, for the next few problems, we want to use a calculator to find theta. We want to, again, round to the nearest 10,000th. So for problem 7, we're going to find theta such that it's greater than or equal to 0 degrees and less than or equal to 90 degrees. So we're told that the sine of theta is equal to 1/9. And again, the reason we have this restriction here is because when we think about this, there's going to be an infinite number of angles whose sine value is going to be 1/9. Okay, so that's why that restriction is there. So we know already that the sine of theta is equal to the opposite over the hypotenuse. And so again, the sine inverse of your opposite over your hypotenuse, or again, you could say the arcsine if you call it that, this is going to be equal to your angle theta. Okay, so we're just going to punch this into the calculator. We're going to say that theta is equal to the sine inverse of your 1/9. So that's your ratio there. That's the opposite over the hypotenuse. And this is going to be approximately, I get 6.379370208, and that's where my calculator stops. Again, I'm going to go to the nearest 10,000th. So tenths, hundredths, thousandths, 10,000ths. So right there, the digit that follows is a 7. So I'm going to add 1 to this. So 3 plus 1 is 4. And I can get rid of all of these. And this answer is in terms of degrees. So the angle that we're looking for, this theta, is going to be approximately 6.3794 degrees. And again, just so this is clear, there's an infinite number of angles whose sine value is going to be 1/9. Okay, let's look at problem 8. So again, theta will be greater than or equal to 0 degrees and less than or equal to 90 degrees. So we have the cosine of theta is equal to 8 over 13. So again, the cosine of theta is equal to your adjacent over your hypotenuse. And so your inverse cosine of your adjacent over your hypotenuse will be equal to, let me make that y better, your theta. So in this case, I can say theta is equal to your inverse cosine of this 8 over 13. That's your adjacent over your hypotenuse. So this is approximately, let's say 52.02012756. That's where my calculator stops. So let's go to the 10,000ths place. So that's going to be right here. So you can see that the digit that follows is a 2. So that 1 would stay unchanged. And we get rid of all this. And again, this is in terms of degrees. So my angle theta is going to be approximately 52.0201 degrees. Okay, let's look at problem number 9. So again, theta is greater than or equal to 0 degrees and less than or equal to 90 degrees. So we have the cosecant of theta is equal to 16 over 11. So once again, you might not have an inverse cosecant key. So we would say the cosecant of theta is equal to, again, 1 over the sine of theta. So all you have to do to find the sine of theta is just flip this, right? So the sine of theta is equal to 11 over 16. So we would say that theta is equal to my inverse sine of 11 over 16. So this is approximately going to be, let's go 43.43253656. That's where my calculator stops. So I'm going to round to the nearest 10,000th. So tenths, hundredths, thousandths. This is the 10,000ths. So I'm looking at that digit that follows. This is a 3. So this 5 stays unchanged. And all of this gets cut off. So this is in terms of degrees. So your theta is approximately 43.4325 degrees. Okay, let's look at problem 10. So theta is greater than or equal to 0 degrees and less than or equal to 90 degrees. And we're given that the secant of theta is equal to 17 over 5. So again, we know that the secant of theta is equal to 1 over the cosine of theta. So my cosine of theta here is going to be, just flip this, so this is 5 over 17. Again, you could just find the reciprocal. I can say that theta is equal to the inverse cosine of this 5 over 17, and this is approximately 72, let's say 0.89536. Let's go 482, that's where my calculator stops. So again, I want to round to the nearest 10,000th. So tenths, hundredths, thousandths. This is going to be the 10,000ths right there. So the digit that follows is going to be a 6. So I'm going to add 1 to that 3. That's going to give me 4, and then cut everything else off. So this is in terms of degrees. So theta is approximately 72.895 degrees.